My favorite one is adapt. Now think about something similar to what you are working on. Here is what you are working on. Then try to think about something similar to this. Okay, and from this similar field, borrow the concepts or techniques to create new ideas. In any fields, there are a number of smart people who created new ideas. Then apply those sophisticated ideas to the problems you are working on. Now, for example, my laboratory has developed a fishing rod approach to identify target proteins of biologically active small molecules. So every time we discover biologically active small molecules, we want to identify the proteins that bind to our bioactive molecule. How can we do it? So every time we discover a new molecule, we biotinylate it. Here's the compound that is called biotin. We biotinylate it. And this is the commercially available biotinylation reagents with the longest linker. Then we conjugate our compound with this biotinylation reagent. Then we make this kind of molecule. So it binds to the protein that is called avidin. Then avidin binds to the Bs so that you can make an affinity matrix. So then we make a cell lysate. We add cell lysate into this molecule. Then the protein that binds to the compound should be isolated. Then at the beginning, we thought the linker is long enough. But we realized that when we look at the crystal structure of avidin-biotin complex, the biotin binding site in avidin is in the deep inside of the avidin molecule. So you need about 7 angstrom to get out from the world of avidin protein. 7 angstrom is this much. So then this entire part is covered by avidin. It's not like this. This entire part is covered by avidin protein. You need this much for the target isolation. So then one solution for that is to make the linker longer and longer. But does it work? I don't think it's going to work. Then I thought it's similar to fishing. In fishing, making the fishing line longer and longer, does it work? Probably doesn't work. You get tangles, then you get seaweed only. You may not be able to catch this nice expensive fish. In fishing, people use fishing rod to cast the bait away and prevent tangles. Then you might be able to catch this expensive fish. So that we borrow the concept from the fishing. We thought the target identification is similar to fishing. I even went to the fishing shop. Then I talked to the people there. Then I borrowed the concept from there. Then this approach works well. The fishing rod we used was polypropylene. Then Later in the lecture, I'm going to tell you more about proline or amino acid or protein structures. The proline is one of the amino acids. If you have polyproline, you get fishing rod-like molecule. If you have 9 prolines, you get 27 angstrom fishing rod-like molecule. Then we synthesize this. Here's a fishing rod-like molecule. We put the glutathione as a bait, the fishing line here, polyproline rod to cast the bait away, then biotin that binds to abidin agarose, abidin bees. Then we actually use this technology for target identification. Then also we borrowed another concept from fishing, catch and release. We put these peptide region. Actually, these characters, these letters, stand for the amino acids. Later in the lecture, I'm going to tell you about single letter codes for amino acids. But anyway, this is a sequence, protein sequence that can be cleaved by the protease. So after catching the target protein, we were able to digest this part, then isolate the target protein. Then we were able to isolate the cyclooxygenase 1, which is the target of indomethacin, an inflammatory drug you can buy in the drugstore. But at the same time, we were able to isolate GLO1. It turns out this is the enzyme that is responsible for the side effect of indomethacin. So then we were able to borrow the concept from fishing in our example. In the next video, I'll tell you more about Scamper method.